It's already recording, so good afternoon once more, everybody. In this session, as I said before, we are going to continue with the part which comes after data wrangling that we saw some weeks ago. Okay, we saw how to load new data frames, how to filter some rows. We saw also how to represent the information by means of plots. We saw also box plots and so on. Okay. So what we are going to do is to transform our data sets or our data frames, because in the previous day we were not transforming the data inside the data frame, but today we are going to transform the data to have it ready for the algorithms that are going to learn from the data. Of course, you have already seen some algorithms with Lucia. I think that you saw some clustering algorithms, right? We are going to focus more in the classification problem, but of course, all that we are going to do here today is also valid for working with other algorithms such as k-means or hierarchical clustering or DB-scan or whatever. Okay. So first of all, we are going to use a dataset that you already have on Moodle. So if you go to the Moodle course of data processes, in the section lab sessions, you can find a file which is called Titanic dataset. Please log into Moodle and download that file. You can also find it in Kaggle because it's a public dataset, but sorry, of course, for that you need to register on Kaggle and so on, and it's easier if you download it from Moodle. So please, I'll give you a couple of minutes to do it. Hugo is asking if I'm going to record the session. Yes, of course. I'm already recording it, okay? And I'll upload it to YouTube. When you download the file, you can see that it is a zip file, okay, containing two different files, one for training and another one for testing. Because as you know, when we are going to learn from data, when we are using a supervised learning algorithm, which is the case of classification, we need to have on one hand the training dataset and on the other hand the testing datasets. Sometimes we only have one dataset. in that case, we need to split our dataset in two different datasets, one for training and another one for testing, okay? Do you know why we need to split the dataset into training and testing? Do you have that clear? Please, if somebody does not, let me know, because it's very important to have that in mind, that we need a part of the data that we have. Of course, it's to avoid overfitting, okay? Because if we are going to test with the same data that we are training, the problem is that we are going to try to guess from something that we have already learned from. Therefore, it's not the best option. The best option is to make the predictions for something that we have not trained with. Okay. Then for this dataset, we have already different datasets. First of all, you have to copy this file, because we are going to work today only with the train part of the dataset, into the same folder that you are going to use as workspace in the Jupyter lab or whatever, any other Python environment that you have. I'm also going to do it. Okay. I'm using this folder. Okay, I already have the train.csv file in my working directory. Okay, and the first thing that we are going to do is to load our dataset. This is something that we already did before with the data wrangling sessions, okay? So we are going to import pandas library, import pandas as PD, and we are going to read the CSV file, pd.read CSV. The name of the file is train.csv. And, well, before doing that, let's take a glance at the dataset. Okay. This is the dataset. If you see, the first column is a passenger ID. Of course, I didn't say it before, but this dataset contains data from all the passengers on board on the Titanic, okay? This is a passenger ID. As you can see, it's just an auto increment value, 1, 2, 3. So it's just an ID column, and we can use the passenger ID column to identify its row. We can use it for naming the index. Therefore, we can set that our index column is the one which is called passenger ID. Okay, and we are going to store this into a variable called df data frame, and let's print it. Okay, this is what we already learned in the previous sessions. You can see here that we have for the index, we have the column that was the passenger ID, 1, 2, 3, 4, etc. Then we have a column. Let's take a more deeper glance into the data. We have here the survived column, the P class, name, sex, age, CSP, parts, ticket, fare, cabin embarked. So, what do you think that survived means? What do you think? This is the first thing that we have to do when we are going to work with a dataset. Try to understand what the variables mean. What is survived? Anybody? If the passenger lives or dies, survived from the wreckage. Correct, of course. It indicates if the passenger finally survived or not after the wreckage. P class? What does P class mean? Passenger class, of course. You can see that, well, in this case, survived was 0 or 1, and P class has values of 3, 1, and 2. First class, second class, third class. Of course, the class in which the passenger embarked. Name, it's pretty clear that it's the name of the passenger. Sex, male, female. Age, the age of the passenger. You can see that even though here we have, for instance, 22.0, in the original dataset, it only stated 22. It converts all the numbers automatically into floats. Okay. And what about this variable? This is a more strange variable, zip_sp. Do you know what this means? Oops. Sorry. I close the navigator. Yes, siblings. Yes, zip_sp is siblings, but siblings is only the first part. Zip_sp, sorry, zip_sp. Yes, and spouses. Well, and spouse, or yes, because there might be only one spouse. So siblings and spouse is the summation of the number of siblings and spouses that are also on board. It's a strange variable because, of course, it depending on the passenger. For some passengers, it might mean the number of siblings, and for other passengers, the number of spouses, or if there is an spouse or not. For instance, if we see, well, there is not a clear case here, but if we see that here we have a passenger with age 50, it's very likely that here, if we find a 1, it's the spouse. But anyway, also the siblings, the brothers and sisters, might be also in the Titanic, so who knows. Anyway, it's a kind of a strange variable, right? And parts, what does the variable parts mean? What do you think? Ostap said it was connected to bed's size on Titanic. I don't get what you mean. What is connected to the bed size? And of course, Blanca is correct. Parts is the okay. I'll be back to CSP. Yes, parts is number of parents and children on board, and sibling spouses connected to the bed size. I don't see why. It's just the summation of the number of siblings and spouses, the number of brothers, sisters, and husbands or wives. Okay, but I don't see the connection with the size of the bed. Do you want to expose why you think that, or should I continue? Okay. Okay. I'll. Okay. Long story. I will look for some information on the internet. Maybe it's related. Well, number of parents and children. Yes, of course. That's the Zuo also said the correct interpretation. Of course, for instance, here we see that this passenger had two parents and children, and also one sibling on or spouse. Here we might think that because see that the age is a missing value. Okay, here we have a missing value in the age. It might be children with two parents and a brother or a sister, or it might be a parent with the spouse on board and with two children. Here we have this missing value, which is not helping to interpret the information from these values, but sometimes it might help. For instance, if we see that here, if we have here a 3, what do you think? What could you do to impute this value if we have a 3 here? Because if you have a 3, what does this mean? That, of course not, this is not the number of parents. Well, that might happen, but it's not very common that you have because if we have a 3, it might mean that I have two parents aboard and one child. But that means that there are two grandparents, I'm one of the parents, and one child. It's not that common that all the family is traveling. Do you think so? Therefore, for me, it would be more usual that it means that I have 3 children. Anyway, it means in any way, even in the way that silly, even in the way that silly stated, or in my case, it means that this person has at least one child. What means that, for instance, the age here cannot be 12. Do you see how we can interpret this to have some information on the value of missing features? Okay, because we are going to use some methods to impute here the missing values. We are not going to take into account these advanced things, but with more advanced imputers, we should take into account these things. Okay, because we are going to impute this value maybe by the average. So we want to skip the missing values. Well, skipping the missing values is not always the best option. Okay, sometimes you can. it all depends on your data. If you are going to only to filter, if you are going to remove only 10 rows, 10 instances from a data set which it is composed of 1000, that's not a problem. But imagine that your data set has 100 instances, and we have a missing value here, a missing value here, a missing value here, and you will remove almost the half of the dataset. That is not an option. We cannot just delete the half of the data that we have because there is only one missing value in one of the features. Okay, we cannot do that. Sometimes, if we are not going to lose a significant proportion of the data, we can, but most of the times it's not a good practice. Okay. Or, for instance, if we have a missing value here, a missing value here, a missing value here, a missing value here, then we can delete that specific row. Sometimes there are rows with very few information. In that case, we can remove specific rows. Okay. But for instance, here I can impute the value of the age just with the mean or the average of all the other samples. Or if it has here a 3, not a 2, I can know, okay, it must be someone old enough to have a child. So, okay, taking into consideration that this was more than 100 years ago, maybe someone could be a parent with at least 18 years old. That was not that common with 18, but maybe 20 or something like that. So 100 years ago, things were quite different. So I could not say here 12. Maybe I can take into account for instance, or I can impute this value as the average of all the people that I know that they have children in the boat. Okay, that's an idea. Okay. Sorry. Okay. So the first thing that we have to do is to know where we have missing values, in which columns we have missing values. Because the first thing that we are going to do is to impute the missing values. Okay. For doing that, we have the data frame here. We can call this method that we don't know, but it returns another data frame. Oh, sorry. What happens? Oh, it is not defined, df. Oh, okay, because I closed it before. Okay. It returns another data frame saying if a value is a missing value or not, is null or not. For instance, we can see that here we had a missing value, and it is also stated like a missing value here. It's a null value. Okay. Okay, but this is not a good summary. To make a good summary, we can call the method any, which returns if any of the rows contains a missing value for that column. For instance, we see that for survive, there are no missing values. Perfect. For the class, there are not missing values. Perfect. The same for name, sex, but of course, as we have already seen, we have missing values in the age. We also have missing values in the cabin. Well, sorry, because I was talking about the variables and I forgot to finish. Okay, ticket is the ticket number of the passenger. Fare is how much they paid. Cabin is the cabin number they were they were assigned to. And embarked is the port in which they embarked. There are 3 ports. I think it's Southampton, S, and the other ones I don't remember what it means, but there are also C and Q. Okay, they are 3 ports of the United Kingdom. S is Southampton, and the other ones I don't remember. It's the first letter of the name of the city. So, going back to this, we see that we don't have missing values in siblings and spouses or parents and children. We don't have missing values in ticket or in fare, but we have missing values in the cabin of the passengers and the port in which they embarked. Okay? So we have to do something with this and this because some algorithms, well, I'm not going to go very deep in how the algorithms work because I think that you already learned the basics about some algorithms in other course of the masters. But some algorithms, most of the algorithms, cannot work with missing values. Okay, I think that decision trees sometimes they can, but most of them they cannot. Therefore, we have to do something with the missing values. We are going to impute the values. But before doing that, we have to take into consideration that we have 2 different kinds of variables. We have these ones and these ones. These are categorical and these are numerical. Well, there are more. For instance, this is not categorical and the name is not categorical and it's not numerical. It's like a text variable. But do you think that the name is important for, well, of course, what we want to do from this dataset is to predict if a passenger survived or not based on the other variables. Do you think that that the name is important for predicting the survival or not? No, it is not important at all. Do you think that there are more irrelevant variables here? Any other irrelevant variable? Yes, name is irrelevant. More irrelevant. Ticket. Yes, the ID ticket. Well, the ID, we are already using it to identify the number of the index of the number of the row. So we have kind of discarded it already. Okay. The ticket, because if you see, the tickets are quite different from each other. It's A/5 and a number. Here it starts with PC, STON. They are irrelevant. Of course, the name, Lorenzo also said it. The cabin, maybe, is fair too. Well, maybe the fare might be relevant, but are you completely sure that it is irrelevant? Okay, for discarding a variable, because we are going to discard some of them. To discard a variable by yourself, you have to be completely sure that it's irrelevant. Fair is correlated to class, of course. And class might be also correlated to know if the passenger survived or not. Okay, I'll comment something about the name. But of course, as I said, fair is correlated with class, and class is correlated with survived. Okay, and what Ilias says about name is also true. The name is or can be correlated with a social indicator. Okay, it's well, I don't see here, but it's very difficult to get that information from the name. You are true, okay, you are right, but here we have a problem because we have to use much more advanced mechanism that we are going to use in this course, because we have to process the names. We have to know which names are more common in a higher class and which names are less common, because of course here we have to detect what is the first name, what is the last name. So that is a problem. That is a big problem, because it's not an easy problem. That is what is called natural language processing, NLP, and it's a quite complicated process. You are right, okay? We can, or we could use it at some point, but we are not going to use it, okay? Because extracting that information is much more complicated, and it's just one variable. And being a social indicator, we can also get that information from the class that the passenger is traveling in, okay? So the effort does not compensate the information that we can extract from here, because we already have that information in the class. Well, I think that cabin is also an irrelevant variable, because first of all, you have to see that we have many missing values. We have a missing value here, missing value, missing value, missing value, missing value. And moreover, it's like C85, C123, B something, C something. Maybe it might indicate the part of the Titanic that the passenger was traveling in. It might be at some point correlated as well. Okay, but from my viewpoint, it's not something that we cannot get from the class as well. And moreover, take into account that we are mixing letters and numbers. So we also need those kind of analysis of natural language processing, okay? And moreover, or it can be considered to be a categorical value. A categorical value are the values that can only take a given values. For instance, sex can only take in this dataset male or female. Survived can only take 0 or 1. P class can only take 3, 1, or 2. So those are categorical values. Even though we can think that they are numerical, actually they are categorical, but encoded with numerical values. They are categorical, encoded with a numerical representation. Okay? And BART is also a categorical variable, but this is not a categorical variable because we have many cabins, different cabins. Okay, so for me, we can remove name, ticket, and cabin. Okay? So we can do that. You remember how we can remove columns? What should I write? df dot, oh, of course. Well, we can use drop. With drop, the data frame is not modified. We obtain another data frame with the columns that are removed. Okay, with pop, it already modifies the data frame. But any of them are valid if they are properly used. So I'm going to remove name. I'm going to remove ticket. And I'm going to remove cabin. Yes, you can also use in place equal to true when using drop. Of course, it's the same, okay? In that case, you modify the data frame, but it's also the same as doing this. Okay, as you can see, there are always different options to do things. And cabin. Okay, it returns the last column that we are removing, because you know that pop returns the column that we are removing. But if we print now the data frame, we already have these variables now. Okay, so what we're going to do is to split our data frame into two different data frames. Why? Well, we're going to use a library which is called Scikit-Learn. Do you already know this library? Well, I think that with Lucia you used it, right? Okay, you used Scikit-Learn or sklearn. Am I right? Yeah, okay. So we are going to import it. Well, no, we are going to import only the modules that we are actually going to use. Okay, but that library has a very specific behavior, and it's that we can only work with values that are numerically encoded. We can have categorical values with encoded with integers, but we cannot have categorical values which are not encoded with numbers, like the columns sex and embarked. So what we are going to do to split the data frame. For doing this, we are going to create a mask which indicates what of the columns are of a categorical value. If I write df dot dtypes, I obtain this. As you see, we have numerical variables. Here we have a non-numerical column, more numerical columns, a non-numerical column. Sorry, no, this is also a numerical column and a non-numerical column here. So if I compare this with object, because the non-numerical columns are returned here like objects, it says that it is true for sex and embarked, the columns that are not numerically encoded. Therefore, we can create a categorical mask with this expression. Okay, and then as this is a mask, we can filter our data frame by this. We can filter it typing df.column and applying the mask, because it's a mask for columns, okay, not for rows. For applying a mask to columns, we have to call data frame.column and here state the filter that we have created. Okay, but as you can see, this does not return a data frame. Well, this selects some columns. It returns a list with the names of the columns that fulfills the mask. Okay, so these are the categorical columns. And now we can call df of categorical columns to obtain only the categorical columns. Okay, we are going to store this into a different data frame df categorical, and we are going to keep all the numerical columns in another data frame df num. We can use in this case the drop method not to modify the original data frame. We are going to drop all the columns that are of a categorical nature with axis equal to 1. Okay, therefore we have here in df categorical columns and in df num numerical columns. Okay, okay, so we had nulls in the column H and in the columns, well, in the column cabin, we don't have it anymore because we have removed that column, but we have nulls or missing values in embarked. We are going to impute first the missing values for embarked. For doing this, we are going to use a function from Scikit-Learn, which is called, or a method, or sorry, a class, which is called simple imputer. To use it, we have to write here from sklearn dot impute import simple imputer. Okay, there are more impute. Sorry, this is an M. There are more imputers, okay, than this, but we are going to use just this one. With a simple imputer, we can impute the missing values by a statistical summary of the variables. We can use more advanced imputers, but this is not the case, okay? For instance, impute here, to impute the port in which a person embarked. What would you do? What could you do to impute the values? If you don't know where a person embarked, what could you do if you have to say something? What do you think? You are set. Okay, I have this person. I don't know where he or she embarked. But if you guess it, you will get a reward of 1,000 euro. What could you do? Any ideas? Yes, I can repeat. We have missing values here in Barked. Well, you cannot see here, but there are some missing values. Okay, we have to impute those values. We have to try to guess what was the port in which they embarked. Okay, we don't have more information. We just need to impute that value. If you are set that you get 1,000 euros if you, yes, the most, that's the answer. If you get 1,000 euro, if you guess the port in which they embark, what would you do? Of course, using the mode. Of course, sometimes you can see, okay, let's see in other, well, you can also use k-nearest neighbors. For instance, you can use other methods, more advanced methods, okay? But we are going to keep a simple approach. But of course, you can use, for instance, a k-nearest neighbors, or you can use any other classification method, okay? You can use a classifier, even if embark is not our target variable. Our target variable is survived, but if you have P class, sex, age, siblings and spouses, parents and children, fair, you can try to guess the port from which the person or the people who has missing values embarked. You can try to guess from the instances that has not a missing value and try to guess or predict the value for the cases in which we have a missing value. That would be a very good approach. So if you do that is very good. But we are going to keep a simple version here. We are going to use the mode. Anyway, as you will have to prepare a project for this, and if you impute nulls with or missing values with a more advanced method, it will be more than welcome. Okay, because you can treat it as a variable that we want to classify and split the set into training, testing, and so on. You can repeat all the process, but for guessing that variable. But here we are going to use a simple method, as I said. We are going to use a simple imputer saying that the strategy to use is the mode. But the mode here is called the most frequent. Okay. I'm going to call it imputer categorical. Okay. Well, when working with Scikit-Learn, we always have two steps. The first step is the fit step, which is in charge of doing the fitting to obtain a function to transform our data. And then we have the transform step, which is the actual step which transforms the data. Okay. With fit, we obtain with something like this. Let me write it. We have here initialized our object, and here we can call dot fit, and with fit we are going to learn the function that transforms our data, and then we can use transform to transform our data. Sometimes if you want to learn the function and right after it transform the data, you can also use the function fit transform. Okay. So we are going to use the fit transform with the df cat data frame. I'm not going to store it, but because I want to see the output here. If you see here, we get an array-like object. Okay, not a data frame. We can still transform this into a data frame, not to lose the names of the columns, the names of the rows, and so on. For doing this, okay, I'm going to call to fit transform with the data frame constructor. I can give an array to the data frame constructor. No, something is wrong. Oh, yes, because it's missing PD. Okay, it's in a data frame, but I have not stated the names of the columns or the rows. For doing that, what I'm going to do is here, right, columns equals to df_cat.columns, copy the name, and I'm also going to copy the name of the index. Now I already have it with the correct name. And I'm going to overwrite sorry, no, not this. df, okay, to obtain the data frame with the missing values already imputed. We cannot see it here because there were no missing values in the rows that are showing here, but we have already imputed them with the mode. Okay. Do you have any doubt on how to impute the missing values with the mode? No? Okay, then I will proceed. The next step, as I said before, most of the algorithms that are included for learning in Scikit-Learn can only work with what is the expression for mean? Okay, we are going to see the mean later, okay? Because we still need to impute the missing values here in the H, okay? So we will see them later, but before I want to finish the transformation that we need to do to the categorical variables. So well, we can check anyway that here we cannot see it here, but we can do this. Data frame dot data frame categorical dot is null any. Now we don't have missing values here. Okay. Okay, we can. Now, as I said before, the algorithms in in scikit-learn cannot work with categorical values in form of text like these ones. Okay, so we are going to transform them into numerical values. To do that, we are going to use first a label encoder. Okay, but take into account that we are going to need a different label encoder for each different column. This is difficult if we have many columns to have a different transformation for each column, because we need to do its transformation one by one. Then what we are going to create is a dictionary of label encoders. Okay, this is not quite evident, but it's that what we need to do. So let's import the modules that we need from Scikit-Learn. We need to import preprocessing, and from collections import default dict, because we are going to use dicts for, dictionaries for having a dictionary of label encoders. So first of all, let's create a dictionary default dict, and I am going to say that it will be a dictionary of label encoders. Okay, and now to transform the data set, what I have to do now is to apply a lambda function to the data frame. Do you remember the function apply that we had in the data wrangling section? Let me show it to you. Okay. Here we had apply, which allows to apply a user-defined function to the data frame. We even defined our own numeric adder. Okay. Today we are going to use this to apply the fit transform function to each different column using a different label encoder for each one. To do this, okay, let's create a different data frame, not to overwrite it. Data frame, categorical, label encoder. And the data frame, I'm going to apply a lambda function. With column, what I'm going to do is dictionary, the dictionary that I created before, whole name. Okay, I can access its different entry of the dictionary with by referring the name of the entry between brackets, and we are going to in this case our dictionary is going to have two different entries, one for each of the columns that we have, sex and embarked. Yes, sex and embarked. Okay, then to each entry dictionary call name. What I'm going to apply is a fit transform of the column. Do you understand this line? Because it might be quite confusing. Yes, because it's I know that this is a little bit confusing, okay? Because it's a very specific way of working with Python. I'm going to apply to the data frame a function, okay? The function is the fit transform, but moreover, the function will be different for each column. Why? Because the function depends on the entry of the dictionary. Okay, the dictionary will have as many entries as columns we have here, sex and embarked. The entries are of the type label encoder. So I will have a label encoder in my dictionary. I will have a label encoder for sex and a label encoder for embarked. And I access and use each specific function of the fit transform of its specific label encoder. Okay, and apply it to the column. So using a lambda function, what we can actually do is to use a different label encoder to transform its different column. Do you already understand this, or should I stop a little bit more here? Okay, don't hesitate to tell me that you need further explications on this, because I know that this is a little bit strange. Okay, we have a dictionary with two entries. Both of them are of class label encoder, but the first one is for the column sex and the other one is for the column embarked. And then what we can do with the lambda function is to get a different entry of the dictionary and therefore call the method fit transform of a different label encoder for each column. Okay, better? Please, if anybody does not know how this works, please let me know. Okay, don't hesitate to do it. Okay, this is enough for transform our data. Okay, after doing this, because I'm already applying the function to the dataset and I'm storing it in another one. Let me print it. You see that what we are doing is, for instance, for sex, we are transforming male into 1 and female into 0. And embarked, depending on the port, 2 is S, 0 is C, and Q is 1. Okay, but do you see any problem with this kind of transformation? Can you highlight any problem with this? Well, here the problem is that we are introducing an order that is not actually in the categories. Here, well, in sex there is no actually order because it's 0, 1. Okay, then there is no an order when we only have two values. But when we have more than two values, we are introducing an order that was not present before. We have now that 0 comes before 1 and 1 comes before 2. Okay, because between 0 and 1 there is no order, because it's just one of them for here and the other ones for here. But in this case, we're introducing a specific order, which is not a good idea sometimes. Okay, because it has no sense to ask if the port in which a person embarked is greater than 1 or greater than 0, because it doesn't have actually an order. Okay. To solve this, we can use a different encoder, which is called one-hot encoder. But before that, let me do something more. We can apply an inverse transformation. Okay, just to show, we can use the dictionary also to create to get the inverse values. Okay, to undo the transformation that we did. If I write df categorical label encoder dot apply, and I apply in the same way a lambda function with columns, I access to the dictionary, call name, and here I call to the method of label encoder, which is called inverse transform of call. You see that we obtain the inverse transformation. Okay, and now I can use here, well, this is not actually needed, but I can call the method transform, but be sure that you are not calling again fit, because fit can only be done once. If we call fit again, we will remove the function that we already learned. Okay. So here, well, it doesn't like it. You should do it in different steps. Okay. We can store this here, well, without transform, and now here call transform, and we will get exactly the same transformation with the same function that we already learned before. Okay, but this is just for you to know. Well, now let's move into one-hot encoding. One-hot encoding is different because what it does is that, let me open a phone. Okay, if we have, for instance, sorry, the name is embarked, well, we can call it port to make it easier. Sorry, I'm trying to write with the touchpad. And to make it easier, also, ports might be A, B, and C. Then it comes again, for instance, an A, or whatever. Okay, one-hot encoding, what does is to transform this single column into 3 columns, one for each value that it can take. Then we would have port A. Let me write it in the other screen, which is tactile. Sorry. Okay. Port A, port B, port C. And we will have, if this is port A, we will have 1, 0, 0. If this is B, 0, 1, 0. If it is C, 0, 0, 1. We have an A again, so 1, 0, 0. Okay? This is what one-hot encoding does. Disadvantages. It may result in a very large number of columns. And of course, only one of them can be one at the same time, okay? But it's better than introducing an order that is not actually present in the variable. Okay, do you understand how one-hot encoding works? Okay, fair. Moreover, it's easier to work with it. Okay, take into account that we are going to use to transform sex, even though we don't need to use it for sex. Okay, for sex, it's better to use a label encoder. Why? Because transforming a variable which is already a binary variable into two different ones, what we are going to obtain here is sex. This was male, right? Yes. In sex male, 1. Sex female, 0. Sex male, 0. Sex female, 1 for this one. Okay? There is no difference at all because we are anyway working with zeros and ones. Okay, we are going to do it here for simplicity, but not to split, because otherwise what we actually need to do is to split this data frame into two data frames, one to be transformed with a label encoder and the other one to be transformed with a one-hot encoder. Okay, but for simplicity we are going to transform the original one also with one-hot encoding. Then from preprocessing, we are going to call the class one-hot encoder, saying that it does not it does not use sparse matrices. Okay, one-hot encoder. Okay, and now let's transform the data frame. Well, as in the previous case, using the imputer, it does not return a data frame, but also a NumPy array. Therefore, we have to create a data frame if we want to preserve the structure. One-hot encoding dot fit transform. It's easier to use than a label encoder, okay? Just fit transform df cat. Well, I'm going to store the result in df cat one-hot encoder columns equals to, well, in this case, the index is easier because the name of the index does not change. It's dataframe categorical dot index. But here the name of the columns are not the same ones, because now we are going to have a column for its original category. Therefore, here in columns, we have to obtain the name of the columns from the one-hot encoder dot get feature names. Df categorical dot columns dot to list. Okay. Now, if I print the data frame, you see that I obtained this. Okay, the get features name returns the actual names of the columns. Sex female, sex male. As you see, we have this here, which is not actually a good thing to do, because actually just one of the columns is the same. Okay, the other one is irrelevant. Okay, because we know that they are complementary. Okay, we can do now this. We can pop, for instance, sex female, and the information that we have is still the same. Okay, it's like using a label encoder with the column sex. Any problem? Can I continue? Do you have any doubt? Anything that you want to ask? No? Are you following me? Are you also doing the same steps? Clearer? Okay. So, okay, we already have our previously categorical encoded variables transformed. Now we are going to transform the numerical values. In the case of numerical values, we only need to impute the missing values. Okay, we don't need to make any of these transformations for transforming into them into a numerical way, because they are already numbers. Okay, so we are going to create a new imputer, imputer for numbers, also a simple imputer. Of course, once more, we can still use more advanced methods. In this case, if in the previous case that it was a categorical value, we could use a classification method. For impute numerical values, what we should do is to use regression methods. Okay, but we are going to use the most simple one, which is actually the mean. Okay, this is the keyword for selecting the mean. It's actually mean, not like in the other one that was most frequent instead of mode. Okay. Then we are going to do the same. Well, we are going to store the result pandas dot data frame, because if you remember, it does not return a data frame. So imputer numerical dot fit transform df num the columns are the same with the names in the previous data frame, and the same with the index. And let's print it. Oh, there's an error. Oh, here, im with m. Oh, it with t. Now, if you see, okay, these ones have not been imputed, but this one has been. Okay, you see that this one has been imputed with the mean, which is almost 30. Okay, so this passenger is considered to have an age of almost 30. We can also impute the values with the median, for instance. Okay, well, it will not have any effect here because the missing values have already been imputed, but we can use the median as well. Depending on your problem, one of them might be better than the other one. Now we can check that we don't have missing values. Df num is null any, and we see that we don't have missing values. Okay. Okay, now we already have the numerical features on one side and the categorical or the previously categorical features on the other side. Now we need to merge all the data frames. We have to combine the data frames into a single data frame. For doing that, we can use the method merge in data frame. Okay, we didn't see the merge method before, but we are going to use it here. I'm going to call df preprocess pd.merge, and I'm going to merge on the left side categorical data frame with one-hot encoding. On the right, sorry, this is an equals. Right, the numerical data frame. And well, if you have followed any courses about databases, you may know that when you are combining different tables, you have to say what is the column in the where clause, or if you use an inner join or a left join or a right join, you have to specify by which column you want to merge the variables. In this case, we want to merge the data frames using the index. Okay, we want to merge these values from the passenger 1 with these values of passenger 1. Okay, this happens because both data frames does not need to follow the same order. Okay, so to clarify, we need to specify what column by which column we want to join, and we need to say here on passenger ID. Okay, to specify that the passenger ID column, which is actually the index in both data frames, is the joining condition. And finally, we can print the data frame, and you see that we have here the same data frame as in the beginning, but with no missing values and no categorical or directly categorical values. Okay, we have here the sex, the port in which the person embarked, whether he or she survived or not, the class, age, siblings and spouses, parts, and fare. Okay. Can you go up a little bit to the codes? Which one? Which part? This? The merge? Okay. But do you understand what I'm doing? I'm merging the categorical and the numerical data frames, and saying that because the order does not need to be the same, okay? And therefore, I have to specify the merging criteria. In this case, I'm merging by the column which is called passenger ID. It's the same as joining different tables in when we do a select in a database. Okay. Anything that you want to mention here? No? Okay. Then let's continue with feature selection. Feature selection is a range of algorithms that are used to select only relevant features for our learning algorithm. Because sometimes, for instance, we have already selected some of them. We have discarded name. We have discarded cabin. But we have selected all these ones. But not necessarily all these ones need actually to be correlated with the class which is survived, which is here. Okay. But there are methods that can guess if the other features are correlated or not. Okay, for doing that, we are going to import from Scikit-Learn dot feature selection import select k best. Okay, select k best. What does is to select a given number of features that are the most correlated ones with the target variable. Okay, it calculates the mutual information between the target, which in this case is survived, and the ones with most mutual information are selected. Moreover, it performs a chi-squared test for doing that. So we have to also import the chi-squared test. So I'm going to create the feature selector, feature selection, k best, chi-squared, and I create the object, select k best using the chi-squared, and I'm going to tell it to select 4 variables, only the 4 most relevant variables for the problem. I'm going to do the fit. Fit. From the data frame that I have obtained here, df preprocessed, and I have to tell it the target column because this is for supervised learning. I want to learn a classifier. Okay, then I need the target column, the target variable, the target filter. Okay. This only fits the algorithm. It does not select them, the columns. Okay, we are going to see the support of each column. Let me so I'm going to call to the function get support. Oh yes, here the problem is that I have not extracted the class column. Give me a second. Okay. I'm going to split the data frame. I'm going to get the class column here from the data frame preprocessed. Sorry. Pop class. No, it was called, sorry, survived. Okay. Get support, what says is well, get support returns an array indicating if a column should be preserved or not. For instance, this says that the first column should be preserved, the second one does not need to be preserved, and so on. It contains exactly 4 true values. So, filtering these columns, I can consider this as a filter. Oh, okay, because this has already happened. Like this. Okay, the column filter, and now I'm going to apply the filter. For applying the filter, be sure that I'm writing it properly. I can access to ilog. Okay, following what I said in the previous sessions, I apply the filter. With this, I get only the columns that the filter, okay, that this print call filter, if you see, I'm getting the first one, which was the sex, then here the class, the age, and the fair. Then I can store this as data frame a best he squared. Okay. These are the most relevant columns for the he squared test. Do you have any doubt about this? Okay, this is performing a chi-square test. We can also do the same. I'm going to copy paste, but instead of with a chi-square test with the what I said before, which is mutual information for classifiers. And here, instead of chi squared, write this. Well, here, instead of chi squared, I'm going to write mi, mutual information. You see here, it still keeps the sex, the class, and the fair, and it changes the age by the siblings and spouses. Okay, there are some differences. Okay, I have a couple of questions. Why did you put class call in other cell? Yes, because I put class call here because as it was, I was re-executing the cell, and therefore it tried to remove the column survived again, and it was not finding a column that was called survived because I had already removed it. So as I wanted to re-execute that cell, I moved it to a previous cell. Okay, that's the reason. And how do you select the number of variables? There is not there is not an easy solution or an easy answer for that. Try and test. Okay, this is one of the disadvantages. There is also another kind of feature selection. I think it's not included. I don't remember. I think it's not included with sklearn, with scikit-learn. But in that case, it's called a wrapper method. What it does is, okay, it starts with an empty set. It tries to add its feature one by one. It gets the accuracy of the classifier, but for that you already need to know the classifier that you want to use. Okay, if it is a decision tree, for instance, let me turn the lights on because it's already dark here. Sorry. Okay. The wrapper approach, what does is that you have to know that you are going to use decision trees. Okay. Then it tries to learn a decision tree with each of the features, and it selects the one with gives more accuracy. Then, fixing that one as already selected, it tries to add another one, and it checks the one which obtains the higher accuracy once more, and it keeps doing that until the accuracy does not improve. Okay, in that case, the number of features is not a parameter of the algorithm, because you have to keep doing that until the accuracy does not improve. That is a wrapper forward approach. There is also a wrapper backward approach, which starts with the whole set of variables, and instead of adding, it removes variables. Okay, but in this case, we need to adjust the best value. There is a specific field in data mining, which is, this is called an hyperparameter, and there is a specific field which is in charge of adjusting hyperparameters. It's not that easy. In that case, the best option is to keep, instead of three sets, training, validation, and testing. And you have to learn with training, adjust your hyperparameters with validation, and then get the actual accuracy with testing. And how? Trial and error. You have to try what is the best option. There are approaches for selecting or for trying in a good order. But what is the best option is not a what is the correct K is not a question that we can answer. It depends on the problem. We have to try and see what happens. Okay? Okay. We are going to leave it here for today. I still wanted to say to you something about discretization and scaling, but I have to be in a master's thesis panel at 6, so I have to finish today here. Anyway, next week I will be here again. I will teach you how to learn some algorithms with Python, how to learn decision trees, SVMs, and so on. And I will finish with the other 2 steps of preprocessing that I'm missing today, okay? So I don't know if you have any question that you want to ask. The codes, yes, sure. I will also upload the codes to Moodle, sure, no problem. I will also upload some slides, okay, with all the information, but I'll upload the code as well. Okay, so let me stop the recording. Thank you very much to everybody for being here today.